So we're looking at using our knowledge about prime factorization to determine if something is a perfect square, a perfect cube, if it is neither of those cases, or if it is both of those cases. So we're going to break them down just like we did before. So 4096 is 4 times 1024. And then I can break down 1024 into 4 times 256. And 256 is just 2 times 128, which can be broken down into 4 times 32. And 32 is 2 times 16, 8 times 2, 4 times 2. I'm going to go off screen, so I'm just going to alter where my tree is going. And I also need to break down all these 4s into 2 times 2. So I'm going to circle all of the prime values at the end of my tree. So you have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 2s. So I could actually rewrite 4096 as 2 to the power of 12. Okay. So looking at that value, I'm going to determine, can I find the square root of 2 to the power of 12? And can I find the cube root of 2 to the power of 12? And just to remember that the value in front of the radical, that is our index. So we're going to check out to see if the exponent can be evenly divided by our index. So in the case of a square root, the index is 2. So 12 can easily be divided by 2. We'd end up with 2 to the power of 6. So it can in fact be a square root. And then let's check to see this one. So we'll look again at the exponent. Can it be divided by the index? Yep, 12 can be divided by 3 evenly. So we get 2 to the power of 4. So it is both a square root and a cube root, which means that 4096 is both a perfect square and a perfect cube. Next up, we're going to look at being able to determine the side length of figures if we know the area and volume of a square and a cube. I'm sorry, my drawing here, it should look more like a square with even side lengths. So we know that the area of a square will have all the same side length. So to find the side length, since it's a square, we want to do the square root of that value. And because we're looking at doing this without a calculator and being able to do this using prime factorization, we'll start by breaking down 1296. So that's just 6 times 216. And 216 is 2 times 108, which is 2 times 54. And 54 is just 6 times 9. And I'm going to continue breaking down any number. So 6 is 3 times 2, 6 is 3 times 2, and 9 is 3 times 3. So I'll circle all of my prime values at the bottom of my prime factor tree and rewrite it as 2 to the power of 1, 2, 3, 4, 2 to the power of 4, times 3 to the power of 1, 2, 3, 4. So to find the square root of this, I'm going to put 2 to the 4 and 3 to the 4 under a set of brackets. And we're going to divide the exponent by the index of the square root, which is just a 2. So this will give us the power of 4 divided by 2. So we are left with 2 to the power of 2. And the power of 4 divided by 2, which will give us 3 to the power of 2, which is just 4 times 9, which is 36. So we are saying that all of the side lengths of this square right here is going to be 36 centimeters. We can do the same looking at this cube, but instead of finding the square root, since the cube, we want to be able to find the cube root. So let's start. Let's find the cube root of 1331. So we'll break this down a little farther. 1,331 can be divided by 11. So it's 11 times 121, and then 121 is 11 times 11. So this one's quite nice because we find that it is 11 cubed if we want to write it as a power of products. And then if we replace 1,331 with 11 cubed, and we want to find the cube root, we take the exponent and divide it by the index, which will just give us a 1. So we're left with 11 to the power of 1, which is just 11. So this is saying that every side length of this cube is 11 centimeters. The last question is going in reverse. So if I start with the volume of a cube, can I find the surface area? So I know the whole volume. So one thing I can find knowing that volume is the side length. So we're going to take the cube root of 729. And this is a nice value that you'll see on the side of our classroom. It is 9. So we know all of the side lengths here are 9 centimeters. So using the side length now, we need to analyze what the surface area of this cube is. So it's going to be the area of one of the squares, which is just 9 times 9. But there are 6 sides, so we're going to have to multiply this by 6. So if I multiply 9 times 9 times 6, I'm going to end up with a surface area of 486 centimeters squared.